So I have kind of an engineering mentality, and I get myself into a lot of random stuff all the time. Today's randomness spurs from me wanting to see how much power my solar setups have, and if the battery's low, high, etc. Alright, so the goal of this project stems from this WT32-Eth01 controller. I use these things for WLED controllers all the time, and they work great. They have Wi-Fi, Ethernet, and Bluetooth on them, and they are super reliable. They run really well on 5-volt power, and yeah, so that's kind of what this kind of all stems from. I essentially want to take the 12-volt power in for my solar setup, plug it all the way into some kind of device that steps it down, obviously, then plug it into the controller so I can get a reading of the device voltage inside of Home Assistant. From what I've seen, there are no devices that do this that are less than about $60 to $200, so I'm obviously not going to spend that much money on this kind of a DIY project, so I figured I might as well just learn the electronics behind it and do it myself for cheaper, probably better, and I can fix it if it goes wrong, unlike the expensive one I found online that I could not fix. So that's kind of, yeah, where this stems from. That's the goal, that kind of thing. I'm not sure if this is going to work. From what I've seen on the Home Assistant threads, people have had mixed luck with the ESP32 with the Ethernet chip. The Home Assistant ESP Home driver doesn't really have a, I guess, driver for the Ethernet controller on this thing, so people are using a similar one, but it doesn't always work, so I'm really curious to see if it's going to work. But the code behind everything else does seem pretty simple, in the fact that it is just essentially just the standard ESP home code alongside a few different lines of code that basically take the reading from this device and convert it and divide it, I guess, do some basic math, because if it is a power factor of 0.00049 or something, whatever, it's going to have to convert that into something that's the actual voltage that's coming in from the battery. So it's a lot going on. I think I can do this. I'm not sure if I can. I'm really doubtful still, but I'm going to get started on this, and I'll give you updates along the way. And we're back. So I had great success working on this, but a lot of failures in the process. So let me kind of walk you through the process that I went through. Excuse me. First of all, I started off with the Ethernet driver. I actually did find a working Ethernet driver. I will put all of the code down in the description below. I think it's going to be super helpful for you if you just look at the code. But with that being said, I did find the code. I got the Ethernet driver working, so it is connected over Ethernet, which is fantastic. The other thing I was also able to do is I wired in the voltage divider, and that actually also works really well. I figured out that you cannot use pin number 2 or any other pin under 35, I think, or 32. It needs to be between pins 32 and 39. The WT32-Eth01 happens to only have a pin 35 and I think 39, so there's only 2 options you have on there. I'm using pin 35 in my code, and that seems to be working pretty well. And I am reading the voltage correctly and identically to the multimeter right now. It is saying it's 12.61 volts. This battery is, and on here you can see, maybe, it says 12.62. Guessing it just hasn't updated here on the reader yet, but anyways, 1 millivolt is not going to matter to me. I don't really care. As long as it's like within a couple volts, it should be okay. I'm just really trying to get a reading of the voltage change when I'm running the heater and when I'm not running the heater, so that's kind of what I'm testing for right now, in this video at least. But I also want to be able to see kind of a graph of the voltage readings over time. As I run this over and over, I want to see how the voltage changes up and down throughout the day and night, to see how much charge I have in the mornings, that kind of thing. So I think this data point is going to be super helpful for me. It's going to be very beneficial in the fact that I actually get to see how much voltage I have periodically throughout the day, especially since these solar charge controllers I'm using don't have some kind of remote management on them. So that will be nice to have, assuming this works well, which I sure think it will. I just need to kind of just watch this and make sure it is the correct voltage. It's not updating on Home Assistant right now, but the battery's voltage shouldn't be changing that much, just periodically. So I'm going to actually grab a heater I just talked about in a recent video. I'm going to plug in the heater, and that should tank my voltage a little bit. And I'm going to see how much the voltage dips here on the screen of the device. So let's get that going. Okay, so this is test number 1. Currently we are sitting at 12.59. Oh, back to 0.6. So we're in between 5.9 and 6, or 0.59 and 0.6 volts. So I want to see what the ESP says on here. It says the last update was about 5 minutes ago, and it looks like it did just log an input here. So if I refresh this, we should see in the update here. Maybe not, you know, because why would this work? It says battery voltage is 12.612 volts still, so I guess it's not insanely accurate, which is okay. Alright, so I'm back working on this again. I think I've got it to a point where I'm comfortable with sharing it. Previously, was not too fond of how much the voltage was fluctuating on the ESP board, but now it's to a point where it's pretty solid. It's not 100% accurate 100% of the time, but it's honestly close enough that I'm comfortable with it now. I don't know why it fluctuates so much. I don't understand that. It's frustrating me, but I think I'm going to leave this project as it is for now. Right now it's measuring every 5 seconds, and it's going anywhere between 12.54 volts, which is what the battery is, to 12.34 to 0.43, 0.45, etc. Not sure why it's fluctuating so much. I'll show you here in a second. But it's slightly annoying, but I'll show you the code and how it works. So this is what we're seeing here on the computer. So if I zoom in, you'll be able to see it easier probably. So this is the log output. So every 5 seconds it outputs a log. The voltage right now, according to the meter, is 12.53. So obviously it's not exactly accurate. I'm not sure why it's not. I don't know if it's because of how often it's measuring the voltage. Actually, you know what? I'll test that. I'm going to adjust the code real quick as I'm recording this, and I'll see if that fixes it. I have not tried this. Everything I've seen online says to do 15 seconds. So I'll do 15 seconds, and we'll see if that fixes it. In the meantime, while it's doing that, I'm going to walk you through the setup and how it's a little better than it was earlier. How I'm getting constant 5 volts to the reader, or the voltage thingy, and then we'll go from there. So let's take a look. Okay, so right here, so we've got the battery here with the voltmeter right here reading it off 12.54 volts, and then over on the computer, that's where I was showing you earlier. If I reload the screen, you'll see that we're reading 12.34 volts. So I don't know if that fixed it or not. Right here we've got a bunch of 12 volt connections going over to the heater, the fan, that kind of thing. This is the voltage thing that kind of divides the voltage by 5. Please excuse my tan line. It divides the voltage by 5, a factor of 5, and then it inputs it to the controller here. And the controller is reading 12.39 and 12.33 volts, so it's clearly still not super accurate. There's a lot of factors here. It could be the voltage divider not working properly, it could be my voltmeter not working properly, or it could be just the ESP being weird, not quite sure. But I've got it wired up to pin number 2 actually. I said not to earlier, but apparently pin number 2 is working pretty well for me, and it's slightly consistent. It's slightly more consistent than it was. So let's take a look here at the code. At the top here, we're using the ESP32-Dev board, not the Rover kit like you've seen anywhere else online if you're doing some research. Next, we've got the battery voltage actual area. It's the sensor, the ADC platform. We're using pin number 2. The name is battery voltage up the interval 15 seconds. Attenuation is 12 decibels. Now, that is something to note, that the attenuation only works for me when it's at 12. 6 divides the voltage by half. Filters, and I'm multiplying by 4.89. This is in millivolts, so the Amazon listing for this said it's 0.000489 or something like that. So I multiply that by 1,000 or whatever that'd be to get that to millivolts. Unit measurement is volts, accuracy decimals is 2, and icon is battery. For the Ethernet controller, we've got the LAN 8270 type on pin 23, 18, and 0. PHY address is 1. Power pin is GPIO 16. We've got some API codes, over the air crap down here. That's about all. If you do any research online, you'll notice there's all kinds of different pins that people say to use. I can tell you I've had luck with pins 2, 15, and 39. I'm not sure if anything works well, if it's supposed to work, if it's not supposed to work. I don't even know, honestly. I'm so lost in this project. But it's to a point where I can trust it. So that's, I guess, what I'm going to do. I'm going to go deploy this for a little while, see how it works over time, see if it gets better, worse, etc. I actually just switched it to pin number 15 as I was talking, and I'm going to see if pin 15 is better, because I've seen anywhere like between pins 10 and 19 or something is good. I don't know. Right now I'm getting 12.489 volts with 2 decimals of accuracy. Not bad. Looks good so far. I'm going to leave it running for a little bit here. But so that's about all for this. Like I said, the code I'm going to link in the description. If I figure out which pin works really well, I will absolutely tell you. If I don't figure it out, I'm not going to comment on it. Just assume that there's probably a better pin than the one I'm using. If you figure it out, please leave a comment down below. I got no idea. I'm new to all this stuff, so I'd appreciate any input you have. This does look, by the way, a lot more consistent. 12.479, 12.508. Sorry, it does look really good. So that's just what I'm seeing now. Obviously, could fluctuate more, could fluctuate less. I'm not sure if it matters. Maybe the power, this building is dirty, sine waves aren't super clean. I have no idea. But all I know is I'm going to end this video here. Please let me know in the description below if you have anything to say. I'd like to hear it. So thanks for watching. Have a great day. I'll see you in the next video.